Okay, hi guys. Okay, listen, we're going to go through everything you did in the quiz today. You can see if you went wrong on anything. Now, what I want you to do, if you want extra practice, and it's a good idea, is that you look at the question, and before I start answering any of the question, you pause the video, try to do it yourself, and see if you can find out where you might have gone wrong today. I've been still marking everything, so I'm not quite done everything, but I figured the best way of approaching this is to give you this video, and that way you can at least see the process by which you answer each of these questions, because the test is going to be pretty much a very similar thing. Maybe a little longer, but otherwise exactly the same. So let's go through it right now. Now, question 1. Graph, determine x and y intercepts, and rewrite as a piecewise function. So right away, let's see what we're going to do. Now, if I do a y-intercept, question is, what do I have to do? Well, I know that I have to let x equal 0, because the y-intercept will happen along that x equals 0 line. So I'm going to be looking at y equals, now here's the question, do I keep or remove the absolute value functions? In fact, I keep them. So it's 1 over 5, 0, there's my 0, my x is now 0, plus 1. And what happens? Well, I get y is the intercept of 1, and that equals 1. And so there I go. So I know that I'm crossing, if I had to actually draw it over here, and I should, is that I already know that there's a point going right through there. Now, next question. What is the x-intercept? So if I do the x-intercept, I am looking at y equaling 0. And in this case, I have dropped the absolute value function. So you have to remember how to do this. You have to remember that if it's a y-intercept, you keep the absolute value function, and if it's an x-intercept, you drop it. So 0 equals 1 over 5 x plus 1. Now if I do this, I'm going to bring over 1. It'll be negative 1. It'll be equal to negative 1/5 x. I know that I'll end up bringing the 5. I look at this. I don't know how you look at this, but I'm probably going to bring the 5 up, and then I'm going to be able to solve it. Actually, what I'm going to end up having is it's going to be a negative 5, and then the negative 1 will come down. It'll be a negative 1, and that'll be equal to x, and that's equal to 5. Look at that again if you're not quite sure about that. So that'll be 1, 2, 3, 4, 5. Now, because I have 2 points of what is essentially an mx plus b, a linear function, it's a line, I can already draw this line. I don't really need to do much else. I know 1, 2, 3, 4, 5, and 1 up. I know I'm going to have something that's basically this. And I can immediately see that there's going to be a portion of it that's going to get flipped. So just by drawing those 2 points, so it's actually good practice of just find your x and y intercept. If you can do that quickly, you can easily find with a line where you're going to flip. And I can see it right now. Here it goes. It's going to flip right there. I'll transform this. I'll flip it vertically. And I'm going to end up making this guy flip. Because anything that's in the negative y area will become positive. That's the whole point of the absolute value function. All y's will be positive. So if any point you've drawn a graph where there's something at the end of things still in the negative y domain, anything below the x-axis, you've definitely done it wrong. And you need to go back and check to see what you're up to. So I've graphed it. I've gotten my y and x intercept. The only thing left, really, is the piecewise function. So if I'm going to remember there, I had, at one point, the line kept going this way, didn't it? It kind of kept going ding, 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 all along here. So what I do know is that the original line is on that side. And then the flipped version is on this side. So how do I describe that? Well, one way of looking at that is that y will equal, this is the piecewise function. First off, I have to say y equals, I have to get my big brackets in. A lot of you guys, what you did is you just kind of ignored the y equals part, but that is essentially how you have to write it. I can't just simply write the right side of this equation. I have to say that y equals it. So be sure to write this part along with everything else. You can't ignore it. Now, what am I going to say? Well, you already know what to do. You're going to say it's either without the brackets, without the absolute value function, it's going to be negative 1/5x plus 1, or it's going to be the negative of that. So you're either going to say negative outside of negative 1/5 x plus 1, all in brackets, or you're going to bring the negative in, and that'll be 1/5 x minus 1. Either one will do. Either one of these will do. I'll just ignore this one for now. And the question comes up is, what one is it? What side of that point? And I can tell which point I'm at. It's the one that hits, it always is actually, where it hits the x-axis, where y is 0, just like I found it here. Where y is 0, the x-intercept is at 5. I know that 5 is basically the dividing line between when I had the original graph and when it got flipped. Now when it gets flipped, that's when things get treated with a negative 1. So this is the second part. This right here is where I've multiplied by negative 1. So that is my flip of the original graph. So the first one is where I have the original line. Well, on the left side is the graph as it was in the first place. So therefore, this, the original graph, taking down the absolute value, is where it must be the case. So that is where it is less than or equal to 5. Which then means that the other side is automatically greater than 5. So see if that's what you got, and we'll move on to the next question. Okay, next question. I want to graph and determine domain and range. I don't need to get the x-intercepts. I don't need to get the y-intercept. Maybe it'll help me if I did. I'd probably have an easier time working everything out. So what I'm going to do is, I do realize that this is a quadratic. It's already in the vertex format. So I automatically know one point. Without even needing to do anything, I already know that I have a vertex, see, at 1, negative 2. Because, of course, this part, I get the flip of the sign, and so 1 and negative 2, there's one of my points. The question is, where are the other ones? Now I can do a few things. I could do a table of values. I could find out where y is at here, at 0 and negative 1, negative 2 or anything. But I could also just find a few points. For example, I could find the, just like I did before, I could find the y-intercept. I don't need to do it, but it's going to help me. So y-intercept is when x equals 0. So y-intercept equals the absolute value of 2 of 0 minus 1 squared minus 2. This is actually pretty easy to figure out. It's just simply 2 times negative 1 squared. Negative 1 squared is just 1 minus 2. All right, cool. And then I'm going to get 2 minus 2. That's going to be 0. So I already know that my y-intercept, here I can even draw it, is right there. And immediately I know that if that's there, and this is my vertex, then I have to have this, since this is my, what would I call this? This is my, give me the word. This is my line of symmetry. Then I can basically draw my happy little graph here. I could get some other points if I want, but honestly, I'm going to be happy as long as you do this. So I already know that the original graph is going to be this. That's the original graph, because I don't need to really get too many points. But now what I need to do is I need to figure out what the actual graph is. Well, as I've already told you, you will be flipping anything that's negative. Well, that's pretty obvious. It's anything underneath. What am I going to do? I'm going to flip it. Here we go, flipping. One of the beauties of Photoshop here enables me to do this pretty quickly, which is nice. Oops. Let's get this kind of lined up here. And what do I got? Yeah. So if you remember drawing something like this, you're on the right track. Now the question is what is the domain and range? Now I'm not asking you to do the piecewise function. You want to take care about that one. Look through the notes to see what would happen if we did the piecewise function for this, because I bet you I might ask you that on the test. But here what I want to do is I want to say, what is the domain and what is the range? The domain is basically, remember how we do it, x such that x And in this case, well, all x's count. This is still, everything's included. There's no point where I don't have an x. So x is a set of all real numbers. Now what about the y? What you're going to notice is that the range for absolute value functions are almost always the same. Why? Because they get flipped right at the y equals 0 line. So there always happen. There might be some cases where this doesn't happen, but in this case, y must be greater than or equal to 0. Y is the set of all real numbers. And you're done. You're done. And that would be everything you would need to do for this question. On to the last one. Okay, not a lot of time, so we're going to go quick. The deal is that for any solving, we're going to do, oh, that's pretty big. All right, let's try that one. I got two cases. For any time I'm solving these, I know that this section here can be either what I see, in other words, it can be x negative 5, and it's all equal to the whole thing, or it's going to be the negative of it, just like I do when I write the piecewise function. So that would be negative outside of x negative 5, and you probably already know what to do there, but no, I'm going to lay it out for you here. 8x plus 15. That's the two cases, and for each I'm going to have to solve it. So what you'll notice is that I'm going to solve for each one, and I got a quadratic in both cases, so I'm going to be getting 4 different numbers. So you can do the work on your own if you like, but I don't have time to kind of go through these in detail. So the first case will leave me with an x squared minus 9x plus 20 equals 0. Once again, I'm going to want to make it equal 0 because it's a quadratic, and then I can get the roots and everything's going to work out. So what can give me negative 9 that multiplied together gives me 20? It'll be a negative 5 and a negative 4. Awesome. And therefore I have an x equals 4 or 5. On the other side, I'm going to get a, well, that's going to become a negative x and a plus 5. I'm going to end up, after I bring everything over, with an x squared minus 7x plus 10 equals 0. And thankfully, another situation where I get really nice factors. You are welcome. X negative 5 and x negative 2, and therefore my solutions here are x equals 5 and 2. So I've got doubles, which is nice. So really, my possible answers, I don't know if I spelled that right, answers is x equals 4, 5, or 2. Now, I noticed on some of your tests, some of you guys actually, I know what comes next. We have to check these answers. Do they actually work? And what I noticed is some of you actually checked 5 twice because you had it twice. But if you plug 5 in there and you plug it in again, I'm hoping you're going to get the same answer. So there was no need to waste your time like that. But, hey, whatever floats your boat. That's cool. So let's check. If we check it, we are plugging in these numbers into the original equation. Not these guys, but the original. So the absolute value function gets involved. So what am I going to get? Well, I'll just give you one of these. I'm going to see what happens. Let's see if I plugged in 4. It would be 4 minus 5, absolute function, and that would be 4 squared minus 8 times 4 plus 15. So what happens? I get a negative 1 absolute value equals 16 minus 32 plus 15. All right, that's interesting. Now, negative 1 absolute value is actually 1. And that equals, let me see, 16 plus 15, that's 31, minus 32, that's equal to negative 1. So what you would have found is that negative 1 does not equal 1. So this is no good, no good, no good. I don't know how you decided to write it in your quiz, but something where I could say no, no good. And then you want to check some others. Don't have time to check the others, so you're welcome to do it yourself and find out which ones work. But I hope that helps you understand where you might have gone wrong during the quiz, and good luck on the test tomorrow. Please study.